Hey everybody, Mrs. Bianchi here. We're looking at question 1, which is a bit wordy, so let's just take it one chunk at a time and work our way through it. It says, select the 3 sentences about the volume of this rectangular prism that are true. So we have to pick 3 of them. And what I did is I took this and I enlarged it just because it'll be easier for me to show you some things. Let's look at choice A. If each cube has edges of 1/8 inch, the volume of the prism is 3/16 cubic units. So let's figure out if one of these edges is 1/8 of an inch, let's figure out the dimension of each length, width, and height in regular inches. So let's count out. So we have 1/8, 2/8, 3/8, 4/8, 5, 6, 7, 8/8. So 8/8 is equal to 1 whole, or 1 inch. So we'll rethink that as 1 inch, and I'm going to substitute that into the formula. Volume equals 1 inch. All right, so again, we're calling this the length. So let's call this the width, and let's count how many eighths we have going this way. 1/8, 2/8, 3/8. We'll substitute that in for width. And for height, let's count going this way, because remember this is 1/8 of an inch. So if we count 1, 2/8, 3/8, 4/8, did you know that 4/8 is equal to a half? So how about we use the simplified version of it just to make it a little more user-friendly. All right, so the height on that is a half. All right, now basically what we're exploring if we multiply these 3 factors together, do we get this number right here, the 3/16? Let's see. If we do 1 times, by the way, some people like to stick a 1 underneath this. If we do, there's no reducing. 1 times 3 times 1 would be 3. And 1 times 8 times 2 would be 16. So we are going to pick this one. A is one of the keepers. All right, let's look at B. We use the same idea, only this time they're talking about 1/6 inch cubes. So let's delete all this, and now we're dealing with 1/6 inch cubes. So we're exploring whether or not choice B might be a possibility. So if this is 1/6 going that way, the length from here to here is 1/6 of an inch. Let's count how many of those that I have. 1 6, 2 6, 3, 4, 5, 6 sixes, so there's 1 inch. 7 sixes, 8 sixes. So the length on that is equal to 8 sixes. Now we can reduce that if you want to. Go ahead and reduce it. We can simplify it by dividing by 2. This divided by 2 would give us 4, and this divided by 2 would give us 3. So in simplest form, that's equal to 4/3. All right, same thing with the width. We're trying to figure out how many 1/6 inches we have going back. So let's count. That's 1 6, 2 sixes, 3 sixes, which would also simplify to give you a more user-friendly version of it, which would be a half. So I say we put in the more user-friendly version of it. All right, and now for the height. If we count sixes, 1 6, 2 sixes, 3 sixes, 4 sixes, which we can simplify that as well. If we divide by 2 on both the numerator and the denominator, this divided by 2 would give us 2, and this divided by 2 would give us 3. All right, so basically what are we doing? We're seeing if we multiply these values together, do we get this 4/9 that they're talking about here? So how about we take advantage of the fact that we can reduce more right here. We can divide by 2 and get 1, divide by 2 and get 1. All right, so the question that we really want to figure out here is 4 times 1 times 1, 4, and is 3 times 1 times 3, 3? If you're saying, yeah, it is, then B is one of the other ones you're going to pick. Remember, we have to pick 3. All right, so how about we skip ahead to another, so you're going to check C and D on your own. Let's look at D just because it has a mixed number and sometimes that throws people off. Let's explore that. So you're going to do C on your own, but let's look at D. So if we look at D, what's a good idea is to rethink this as an improper fraction. And if we rethink that as an improper fraction, it's something ninths. We would multiply this times this, which would be 27. So let me write that number down so we can look at it. And then we have to add in the 5 So this plus this would give us 32/9. All right, and we're talking about 1/3 edge cubes. So let's count out our thirds. And let's write the formula again, which is volume equals length times width times height. All right, so volume equals, and let's count out our thirds, because this is 1/3, right? If the edge cubes are 1/3, that's 1/3. So that would make 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So that's equal to 8/3. That can't be reduced, so let's just go ahead and substitute that right into the formula. Going back this way, we have 1/3, 2/3, 3/3. Now 3/3 can be simplified. How about we just rethink that as 1, which is the same thing as 1 divided by 1. And for the height, we're going to go up 1/3, 2/3, 3/3, 4/3. 4/3 is the height. Not seeing any reducing opportunities. So here's what you need to do to determine whether or not D might be one of the ones you're going to pick. Multiply 8 times 1 times 4 to see if you get this. Multiply this times this times this to see if you get this. And if you do, then you're going to pick that one. All right, so I would expect to see similar work for choices C and E, even though we didn't do those together on your paper, just to confirm that which 3 are actually correct. All right, now there's another video if you prefer doing ratios that you can watch that shows you another way of doing this. Feel free to watch that if you like ratios, but honestly I think since as of right now we haven't done the ratios unit, so they change the order in which things are done. So this is probably going to be your best bet to do this approach.